Welcome back. And for the ones who have missed 3AI Youth Event, a back to back solo leadership sessions, we have covered four of them. This is a unique 6 by 12 AI event, anthology series format. Speakers are coming in and talking in a 6 or a 12 minutes format, three themes, different narratives. And I'm here to introduce the fifth speaker of the day, Ishu Jain. Ishu is Director Data Science and Analytics at Swiggy, and she would be talking about a sneak peek into AI first enterprise. Before she comes on stage and talks about AI first enterprise, let me give a brief about Ishu. Ishu is the Director of Data Science and Analytics at Swiggy, and she's a seasoned analytic professional with a diverse work experience in delivering analytics insights in companies like Dell, Genpact, Fractal, and Target. And here she would be talking about AI First Enterprise. Ishu, over to you. Thank you.
Hi everyone. Today it's an absolute pleasure to talk about my personal experience of working in an AI first enterprise. It was also my first experience when I joined Swiggy, and I was very happy to know that how every decision which is taken in the company is always data backed, and whatever we want to do in future, we never think of how we will really do it because we believe we'll either have data science, analytics, AI. There are so many things we have that we will make it a reality. So let me take you through the journey of some of our use cases, specific about addresses in the next few minutes. Something about Swiggy. We are definitely the largest food delivery platform. We are operational in 500 cities. We deliver in 32 minutes, like our average delivery time is 32 minutes. We also have 6 CR unique addresses. So imagine the kind of volume we handle and all our decisions handle, how many lives we touch. And also 99% of our orders, in fact, it is slightly more now since the slide is dated, we deliver within 60 minutes. So how do we really do it? What does it really mean for us? So let me talk about that. That how do we improve the speed of delivery, yet reduce the cost of delivery, yet not compromise on our driver experience and safety, and also make sure that we cater to all the zones, all the far-fetched areas. It's a very difficult rope to rope to walk, right? Because you want to be right by all three parties, right? So which is where analytics and data science plays a key role. In terms of restaurant, we want to make sure that the customers has the right selection of restaurants. We also ensure that restaurant experience is good, like our restaurant partners are getting the fair share in terms of the discounts they offer us or the commissions they have to give to us, right? So how do we ensure profitability for our restaurant partners? Then we also want to optimize the advertising revenue we get from the restaurant partners. Again, you will realize, right? It's a thin rope to fall. We want to be right by our customers. We want to be profitable as a company. And we also want to ensure that our restaurants are getting their fair share in terms of profits. From the application perspective, analytics and data science plays a big role in optimizing the UI to drive better conversions. What kind of search engine optimization to run in the backend? How which restaurants come at the top? Is there a personalized combo we can offer to the customer? And also where we see gaps in conversion, where we see the customer journey is breaking down, how do we ensure we introduce features for those, where do we introduce those features? All these decisions today in Swiggy are empowered with data. They are not taken by intuitions. So it's actually a very strong proposition. Even the measurements of once we launch something, they are done in a very detailed manner. However, today I will talk about one such use case. If we look at delivery, we leverage data science to optimize each leg of delivery and we call this as CAPRD. What does it mean? Once the order is placed on the application, it's confirmed, and the confirmation trigger is sent to the restaurant. At the same time, a trigger is sent to the driver or the assignment cron, which we have, to assign a driver. Once the confirmation is received, the food gets started prepared, and the driver, once assigned, is on the way to the restaurant, which we call the first mile. Then once the driver reaches the restaurant, he has to wait at the restaurant to pick up the food if the food is not ready. And once he picks the food, the distance traveled from the restaurant to the final destination or address of the customer is called the last mile. So if you see, we want to optimize all of this. The first mile, which is the distance between wherever the driver was to the restaurant. We want to optimize the wait time at the restaurant, not too much and not too less. So it has to be an optimized number so that the food doesn't get cold, or he's not waiting unnecessarily and wasting time. And then the last mile, where the distance is covered from the restaurant to the customer. Again, it has to be an optimized time, because we don't want the food to be stale or cold when it reaches the customer. We do not want to, and we don't want to be late, and we also don't want to reach very early, because the customers even don't appreciate that. So all these things are optimized. One such use case which we hear is, we wanted to avoid this, right? It's a very famous line, Madam Kidhar aana hai. So we have these drivers who call our customers ki kahan aana hai, and these calls are usually annoying, because the customers are like, I've put the address on the application and now just follow the route, and why are you really calling me? And now when it comes to the driver, he is in a fix because he's actually not able to find that address. So what is going on, and where can we do better, right? So we always listen to customer problems, and we have a very active Twitter handle. Even on LinkedIn, we have support groups where even individual order IDs are looked up to, friends, families, all of that, right? So one of them is this, right? Why don't the riders give a call to know the directions every time they delay by 15 minutes because they reach somewhere else? It is a place that is similar. It sounds similar. So we found that this is a genuine problem, and hence we build an intelligence to solve it. So what did we actually do, right? So we figured out that there are a host of addresses which the problem is the lat longs, or the geohashes we capture as when the application opens. So we realized that a customer can order from various addresses within a vicinity of geohashes. So if you open your application, let's say in your building, versus you open a application in the next building, the reverse geocode, or the way we call it, the address which gets captured could be different. However, you don't realize it. You've captured it by default, and you think the home address will be default address. And then, uh, because the driver sees something else, he's confused. Kahan aana hai, right? So what did we do? We looked at the location data of all the delivered lat longs for an address showed to us. So we realized that there are a lot of geohashes which are in the vicinity of that one home address or one office address, right? And hence that location is not exactly what the customer is telling us on the phone, or which is where they exactly live, right? Or sometimes it's differently understood by the driver. So it was the problem, right? As you see in this graphic, right? All of these geohashes are around, or the lat longs are around that home address, right? And this was a problem. So what did we actually do? We actually looked at all these addresses. we figured out a algorithm which is also called the density based clustering. So what does this really do? A density based clustering looks for these uneven clusters, as you would see on your right. uh, a k means clustering would try to make uniform looking clusters. However, a density based clustering can come with different shapes and sizes. And the way it will operate is that it will look at the nearby delivered let longs within a certain distance threshold specified by the data scientist. So what will happen is it will provide a centroid, but then start making judgment calls about all customer lat longs for that address. And till the time they meet this minimal distance bar, they become the core point of that address. And in case we find enough core points of that address, we are sure that yes, the home address is where the customer is ordering from. It is not the lat long which is being shown on the application, it is actually the home address. And hence, we ended up correcting almost 1.2 million addresses like that. So, we didn't let the customer know that we are doing this exercise, we didn't let the driver know that we are doing this exercise, and then we made sure that we update these addresses where the model confidence for correction was extremely high. And we actually got on ground impact. The last mile time, as I've said, last mile is the distance from the restaurant to the customer, reduced by 10 minutes for many customers. The average delay was reduced by 5%, and the need for the driver to call the customer again and again also reduced significantly. I also want to specify it's a very tricky thing to do, because if we correct this incorrectly, then it will cause more burn with the customers. They will be very hassled, and we want these instances to be minimized. So whenever we do these exercises, we do with very heavy experimentation. We move very slowly. We see if we are looking at some on ground disruptions. We usually keep correcting our models till the time we get the optimal results. So this feature was definitely a win-win for the customer, for the driver, and for the company. Let me know if you have questions. Please reach out to me, and I will leave my details with the presenters.
That was Ishu Jain talking about a wonderful case study of Swiggy, a food app platform catering to 1.5 to 2 million orders a day. And imagine the quintessential question of, Madam, where do you want me to come? Is something what they're trying to solve in terms of density-based clustering mechanism. A great, I would say, manifestation of how AI-led enterprise should be working upon, and that's where Swiggy and Ishu Jain talked about wonderfully about this particular case study. Thank you so much, Ishu, for your time. Really appreciate.